This is exercise 13C, question 9a. Differentiate x e to the power of x and hence find the integral from 2 to 0 of x e to the x dx. So let's just start with part A. If y equals x e to the power of x, we would use product rule because we can see two functions in x. So u is x, u dash is 1. V is e to the x and v dash is also e to the x. So therefore your first derivative, y dash, is u v dash plus v u dash, which is x times e to the x plus v is e to the x times 1. So hence, if you differentiate x e to the x, you will get x e to the x plus e to the x. So if I differentiate x e to the x, I get x e to the x plus e to the x. Remembering that integration is the reverse process of differentiation, hence, if I integrate x e to the x plus e to the x with respect to x, so dx, I will get x e to the x. Now, part B of the question, actually I could start from there. Part B of the question says, hence find the integral from 2 to 0 of x e to the x. So I just want to integrate this bit, not that. Now, if you're integrating x e to the x plus e to the x, it's like you can integrate them separately and you will get the same thing. So I can just break this up. So x e to the x, the integral of x to e to the x plus the integral of e to the x, or plus all of that, is, I can separate them, is integral of x e to the x dx plus, if you want to do this one integral with two parts, basically you can integrate separately. It's the integral of x e to the x dx plus the integral of e to the x dx. So doing that is the same as this. Now we know that that equals, so if you integrate all of this, you get x e to the x. Now the reason I've broken this up is that I just want to integrate x e to the x with respect to x, so dx. So I want to integrate x e to the x dx. Not going to worry about this 2 and 0 yet. Let's just do it as an indefinite integral first. So therefore I could say that the integral of x e to the x dx would be just x e to the x minus the integral of e to the x dx. Now we know, so all I've done is basically inverse operation, take this over. So therefore the integral of x e to the x dx is x e to the x minus, now the integral of e to the x is e to the x plus c. Okay, so now I can answer the question. Therefore the integral from 2 to 0 of x e to the x dx is x e to the x minus e to the x, with a substitution here between 2 and 0. So it would be 2e squared minus e squared in brackets minus 0 times e to the 0 is 0 minus e to the 0 is 1. So therefore, now 2e squared minus e squared, they're like terms, is just e squared minus negative 1 is plus 1. So that's the answer therefore, and the word solution for 9. It's another question from question 7, exercise 13C. It says, again, remembering that, I'll just put it over here, that if y equals e to the function of x, that y dashed equals e to the function of x times the derivative of that function. In other words, it's equal to f dashed x e to the function of x. Now, if we differentiate that, we get the derivative. So therefore, if we integrate f dashed x e to the function of x, we get e to the function of x. That's what that first line is saying. If you integrate something of this format where the front bit here is the derivative of that function, then you'll just get e to the function of x plus c. So what we're going to do, let's just write down over here that our function in x here, remember if this, we want to put this in the format f dashed x e to the function of x. So if our function of x is 3x squared plus 6x, then f dashed x is 6x plus, sorry, I've made a mistake, that's 3x squared plus 4x. Then the derivative is 6x plus 4. Now, we know that that seems to be double what this is, so it's 2 lots of 3x plus 2. So if you want to integrate this, what we know is that we can actually integrate 6x plus 4 instead, or we can integrate 2 lots of 3x plus 2 times e to the 3x squared plus 4x plus 1. We know how to integrate that. So we're saying if we're trying to integrate this, it's like integrating that. But notice I seem to have an extra 2 here, so I just adjust the coefficient. So a half times that gives me the actual question that I'm dealing with. So therefore, if we integrate 3x plus 2 e to the 3x squared plus 4x plus 1, we will get a half times e to the function of x. So a half, because the integral of all of this, okay, the integral of all of this is e to the function of x. So I get, again, I'll just write it down here. I know I've done this function of x and f dashed x here. What the question really is if I start with e to the 3x squared plus 4x plus 1, that is my e to the function of x. Then when I differentiate it, I will get 6x plus 4 e to the function of x, which is 2 lots of 3x plus 2 e to the function of x. So if I differentiate that, I get this down here. So therefore, if I integrate that, I get this top line up there. So I'm just using that now that I know how to integrate this to bracket 3x plus 2, etc. So when I integrate that, I just get e to that function, which is e to the 3x squared plus 4x plus 1. And of course, we get plus c. So that's how we do that sort of question. Okay, we notice that this term in front is almost the derivative of that. It just seems to be half of it. So you know how you have to put what you're supposed to do here. You definitely need the f dashed x e to the function of x here, but then you adjust this adjustment of this 2 out the front with a half. Okay. And question 9. Now this is question 13a. Differentiate y equals x squared e to the negative x squared. We'll look at part B in a minute. Okay, so looking at part A, if y equals x squared e to the negative x squared, we've got that u is x squared, u dash is 2x. Now v is e to the negative x squared, and v dash is, remember differentiating, it's e to the negative x squared. And we're differentiating e to the function of x. When you differentiate e to the function of x, you get e to the function of x times the derivative of negative x squared, which is negative 2x. So you get negative 2x e to the negative x squared as that derivative. So just be careful there that you don't mix up differentiating and integrating. So y dash, the derivative is uv dash plus vu dash. So u times v dash will be x squared times negative 2x e to the negative x squared plus v is e to the negative x squared times u dash is 2x. So just going to write these two terms out. I would have negative 2x cubed, and simplifying. So I've got negative 2x cubed e to the negative x squared plus putting the 2x in front, 2x e to the negative x squared. Okay, that means if you differentiate x squared e to the negative x squared, you will get negative 2x cubed e to the negative x squared plus 2x e to the negative x squared. Remember, that's differentiating. And integration is the reverse process. If I integrate this answer here, I will get that there. So we're going to start with that. Notice they're asking us to integrate x cubed e to the negative x squared. Now we don't quite have that, but you know, we'll have to adjust coefficients somewhere. So what we know is that the integral of negative 2x cubed e to the negative x squared plus 2x e to the negative x squared dx is, so if I integrate that, I get this up here. It is x squared e to the negative x squared. Now remembering, I can break these two up, and I'm actually going to take the coefficients outside as well. So negative 2 times the integral of x cubed e to the negative x squared dx plus 2 times the integral of x e to the negative x squared dx. Remember, these 2's are just constants. So negative 2, the integral of negative 2 times that is the same as negative 2 times the integral of that. So the constant does not affect the integration. So just breaking this up and taking the constants out, I've got that. Notice I'm trying to integrate. The question is to integrate x cubed e to the negative x squared. So why don't I divide? Now this is an equation. I can divide both sides by 2. So dividing through by 2. Dividing each side of the equation or each term by 2. I will get integral of x cubed e to the negative x squared dx plus integral of x e to the negative x squared dx equals this thing over here divided by 2. Okay? And so therefore, the integral of x cubed e to the negative x squared dx equals this, which is x squared e to the negative x squared over 2 minus the integral of x e to the negative x squared dx. Now the thing is, you have to work out what this is. So I'm just going to stop here for a minute. I'm going to work on the side over here to evaluate the integral of x e to the negative x squared. Now, what we're going to think of is that we know how to integrate f dash x e to the function of x. So if you integrate, now actually I'll explain why. If y equals e to the function of x, then y dash, the first derivative, is f dashed x e to the function of x. Remember, it's e to the function of x, the derivative. It's e to the function of x times the derivative of this function. So the derivative of e to the function of x is f dashed x e to the function of x. Hence, if you integrate f dashed x e to the function of x, you get e to the function of x. Okay? Now we're going to look at this second bit using that. So the integral of x e to the negative x squared, if we want to try and do that, just over here, my function in x is negative x squared. So f dashed x, I would really like it to be negative 2x. Problem is, it's not negative 2x out the front there. So what I'm going to do, I'm going to do some readjustments. Okay? So even though I'm trying to integrate x e to the negative x squared dx, what I can integrate is negative 2x e to the negative x squared dx. I can integrate that because I can integrate f dashed x e to the function of x. Okay, so I know here that my function in x is negative x squared and the derivative of that is negative 2x. So I know how to integrate that, but I need to make this look like that. And the only thing that's stopping this from looking like that is this negative 2. So I have to balance out or adjust for this negative 2 on the numerator, and that would be a negative 1/2 out the front. Because if you multiply negative 1/2 by negative 2, you get positive 1. They will cancel, and it just looks identical to the question. So therefore, this integration of x e to the negative x is the same as negative 1/2 times the integral of negative 2x e to the negative x squared, which is negative 1/2 times, remembering that if we differentiate, so sorry, I should just finish this off. Back over here, if I have y equals negative e to the function of x, in other words, e to the negative x squared, then y dash is negative 2x e to the negative x squared. That's what I was trying to do. So therefore, if you integrate negative 2x e to the x squared, you'll get e to the negative x squared. So I'm trying to integrate x e to the negative x squared. It is the same as integrating doing negative 1/2 times the integral of negative 2x e to the negative x squared. So it'll be negative 1/2 times the integral of this is just e to the negative x squared plus c. Okay, so I'm going to replace the integral of x e to the negative x squared dx with negative 1/2 e to the negative x squared plus c. So I'm going to do that up here. You can't actually see that on the screen. So I'm going to continue from here. So therefore, I've just worked out this bit now. Okay, so therefore the integral of x cubed e to the negative x squared dx equals x squared e to the negative x squared over 2 minus the integral of x squared e to the negative x squared. Now I've just done that, and it's negative a half e to the negative x squared, so I'll put that in. So it's minus negative a half e to the negative x squared. And I may as well put in a plus c here now. So just combining like terms, I've got x squared e to the negative x squared. Now this minus negative is plus. Notice I've got 2's on the denominator, so I've got a common denominator here of 2. And I've got plus e to the negative x squared. And I'll just put this plus c over here. Okay. Now, this is almost what we need. We can just see that we've got a common factor of e to the negative x squared over 2. So if we pull out e to the negative x squared on the numerator, we're left with x squared plus, well, this other term here must be 1, and then we've got plus c. Made a little mistake, and I'm hoping that you've picked it up somewhere. Notice that I'm supposed to be getting negative e to the negative x squared over 2 x squared plus 1 plus c. But I've got positive. I got positive here. So I've made a mistake somewhere. And I can see where that mistake is here. And because I've divided through by 2, I either need to divide through by negative 2 or... So if I... Actually, all I have to do is fix this here. If I divide through by 2 here, I've still got a negative there. So I just need a negative there. So divide that by 2, I've got negative 1. Divide this by 2, it's positive. Divide this by 2, it's that. So just fixing this up here. This will be the negative integral of this. It's the negative integral of that. There's still a negative here. This has gone to the other side. Okay. I've still got a negative here, the negative integral of that. So therefore, the integral of x cubed e to the negative x squared dx is negative of this, negative e to the negative x squared over 2, bracket x squared plus 1 plus c. Okay? All right, what we might do is practice a few more like this over here.